So, let's talk about the dark side of AI. We're handing over more and more of our lives to artificial intelligence, our cars, our finances, you name it. But in doing so, we're accidentally creating a whole new playground for cyber threats. It's a brand new world of vulnerabilities, and we're going to get right into it. Okay, before we really dive in, just a quick heads up. What we're doing here is a high-level overview. The really deep, comprehensive tutorial comes from Virtualization Options LLC. So if you want the full-blown technical breakdown, that's going to be your go-to source. And this quote, man, it just hits the nail on the head. It perfectly sums up the challenge we're up against. This isn't just about some cool new tech. It's a perfect storm of risk. See, the very thing that makes AI so incredibly powerful, its ability to learn, to adapt, is also its greatest weakness. Now, this is absolutely crucial to understand. Attacking an AI is a whole different ballgame than traditional hacking. You can forget about looking for bugs in the code, like an SQL injection. AI attacks go straight for the brain. They target the data, the logic, the learning process itself. They are sneaky, they're incredibly smart, and maybe the scariest part? As you can see here, they often leave no fingerprints behind. All right, so how do we even begin to wrap our heads around this new battlefield? Well, thankfully, we've got a roadmap. We're going to use a framework from the National Institute of Standards and Technology, NIST. They've broken down these new threats into four main categories, and that's going to be our guide for this whole explainer. First up on our list, evasion attacks. And the name here is a total dead giveaway. This is all about fooling an AI that's already trained and out in the world. An attacker crafts some kind of malicious input, something that looks totally normal to us, but it sends the AI into a complete tailspin, causing it to make a huge and often catastrophic mistake. And this right here is where it gets genuinely scary. This isn't theoretical. Researchers have actually proven that you can add a tiny bit of digital noise to this stop sign, a change so small you and I would never ever notice it, and it can make an autonomous car's AI see a speed limit sign instead. I mean, just think about the implications of that for a second. It's terrifying. Okay, next up we have poisoning attacks. Now, if evasion is about tricking a finished AI, poisoning is it's like slipping a toxic ingredient into the cake batter before it even goes in the oven. The flaw isn't something you exploit later, it's baked right into the AI's core from the very beginning. And this isn't some random act of digital vandalism. As these steps show, it's a carefully planned, methodical heist. The attacker has a goal, they craft the perfect piece of poison data, they find a way to slip it into the AI's training set, and then they just wait. They wait for the right moment to exploit the hidden weakness they've built. So what does that look like in the real world? It looks like a secret backdoor. Imagine a facial recognition system at a high-security building. It's been poisoned to believe that one specific, ordinary-looking pair of glasses is a universal master key. For literally everyone else, the system works perfectly. But for anyone wearing those glasses, it's a wide-open door. Our third category is privacy attacks. And this is where things get, really personal. This is all about turning the AI itself into an unwilling spy. See, sometimes AI models accidentally memorize bits of the sensitive, private data they were trained on. These attacks are designed to force the AI to spill those secrets. And this is one of the most chilling examples out there. It's a technique called model inversion. And honestly, it sounds like something straight out of a sci-fi movie. An attacker can essentially play the AI in reverse, using its public predictions to literally reconstruct the private, sensitive faces it was trained on. It's like pulling a photo right out of the AI's memory. And finally, we have abuse attacks. Now, this one's a little different. Here, you're not trying to break the AI or find a flaw. No, you're weaponizing it. You're using the AI to do exactly what it was designed to do, but for malicious purposes. A perfect example of this is deepfakes. A criminal can use an AI to create a flawless voice clone of a company's CEO. They call the finance department, sound exactly like the boss, create a sense of urgency, and trick an unsuspecting employee into wiring millions of dollars. The AI is doing its job perfectly. It's just the perfect tool for fraud. So, up to this point, we've talked all about how people can attack AI systems. But what happens when we flip the script? What happens when AI becomes the attacker itself? That's what we're going to dig into next. Phishing is the perfect case study here. We've all seen those clumsy phishing emails, right? The ones with the bad grammar, the generic "Dear Sir" or "Madam." They're usually pretty easy to spot. Well, AI has completely changed the game. It can now create hyper-personalized, eloquent messages with perfect grammar that are almost impossible to tell apart from the real thing. And the results? They speak for themselves. This chart shows the difference in black and white. AI-powered phishing is 5 to 7 times more effective than the old-school methods. I mean, look at that jump. From a 4% success rate all the way up to 21%. That is a massive advantage for the bad guys. So here's the bottom line, the one thing you really need to take away from all this. AI is a true double-edged sword. On one hand, it's creating these brand new complex vulnerabilities we've never had to think about before. And on the other hand, it's taking all the old familiar attacks and making them more powerful and more lethal than ever. Which leaves us with a really big and, frankly, kind of scary question. As we let AI make more and more of our decisions for us, as it becomes the gatekeeper to our world, how on earth do we defend ourselves against attacks that target not just our computers, but our very perception of what's real? That's the question we all need to start asking ourselves.